Greetings, dear learners. We were learning asphyxiant gases, in which we learned what is asphyxia, their cardinal features, the classification of the toxic gases, and finally the poisoning due to the ammonia. Continuing with the same, today we will learn the remaining asphyxiant gases and how to collect samples in cases of the toxic gases poisoning from the post-mortem examination. So let's begin with the hydrogen sulfide. Recently in Ludhiana, that is in Punjab, a terrible accident happened. 11 people, including the 3 kids, died because of the dangerous gas leak. It all started early in the morning near a store where the people went to buy the milks. A terrible smell like the rotten eggs filled the air and the people started feeling sick. The National Disaster Response Forces, that is NDRF, came quickly and found a lot of bad gas called the hydrogen sulfide in the vicinity. They think that it came from the factory putting chemicals into the sewer. The accident was awful. Families lost the loved ones, including the kids and the parents. People tried to help, but it was too late for many. The whole neighborhood felt sad and scared. Officials tried to figure out what happened and help those hurt. They closed off the area and checked for the more dangerous gases. Leaders promised to help families who lost someone. The accident made everyone to realize the facts about the sewer gas and their quick impact on the human health. So this was the incidence that was because of the sewer gas that led to the death of the 11 peoples. Such type of incidences are regularly reported in the media. Many of the persons who are going for the sewer work, they are the laborers who work as the manual scavengers, and they don't use much of the protection and they many times die in the poisoning due to the sewer gas. So what is sewer gas? Sewer gas is basically mixture of many gases that includes hydrogen sulfide, ammonia, methane, sulfur oxide, nitrogen oxides. They are produced and collected in the sewage system by decomposition of the wastes. So one of the most important constituent in the sewer gas is the hydrogen sulfide, and many times the hydrogen sulfide has replaced the sewer gas acronym, and often sewer gas is identified by hydrogen sulfide only. So here also, although the mixtures would have contained the many gases, but the diagnosis was mainly and the result of death was mainly due to the hydrogen sulfide poisoning. Sewer gas is also known as knockdown gas as it causes immediately inability in the patients and he falls down to the death immediately after the inhalation. So this is known as the knockdown gases. Then coming to its main constituent, that is the hydrogen sulfide. Hydrogen sulfide is a colorless flammable gas with a distinct odor of the rotten eggs. It can be produced naturally as well as through the industrial processes. Naturally, it is generated during the breakdown of the organic matter containing the sulfur, and it is prevalent in the cesspools, sewers, swamps and the volcanic gases. By the industrial process, it is emitted as a byproduct during the distillation of the petroleum oil, in the manufacturing of the artificial silk and various industrial settings utilizing sulfur compounds. Hydrogen sulfide is denser than air, tending to accumulate at the ground level. So the poisoning is seen at the ground level or the below ground level, not at the higher level by the sewer gas or the hydrogen sulfide. This is important to note. Then the mechanism of action of the hydrogen sulfide is that it inhibits the cytochrome oxidase enzyme, and also it has interaction with the various macromolecules and the enzymes. By inhibition of the cytochrome oxidase, it acts similar to the cyanide and the phosphine gas, binding to the cytochrome C oxidase and disrupting the cellular respiration. H2S interacts with the enzymes and the macromolecules, disrupting the disulfide bonds and inducing various physiochemical effects. Fatal dose of hydrogen sulfide is 20 ppm. This is the maximum alloyal concentration of the hydrogen sulfide. 400 to 700 ppm is dangerous to life after an exposure of half an hour to 1 hour, more than 1000 mm is instantly fatal to the humans. Fatal period is few minutes to the few hours. Then on its exposure, acute presentation are seen according to the concentration. At the low concentration, that is less than 250 ppm, manifestations include the cyanosis, irritation of the mucous membrane and the respiratory distress. Moderate concentration, that is between the 250 to 500 ppm, it presents with the CNS and respiratory symptoms, cardiovascular effect, skin irritation and the muscular weakness. At high concentration, that is around 750 to 1000 ppm, it is characterized by the weakness, cardiovascular and the CNS disturbances, including respiratory failure and the death of the person. On chronic exposure to the hydrogen sulfide, it may present with the headache, weakness, nausea and the visual disturbances. Basal ganglia abnormalities and the spontaneous abortions are observed in some cases among the pregnancies. So, as we already discussed, this acts by the asphyxiant sign and symptoms and it is irritant gases. So, they act by both the mechanism, irritation of the mucous membrane as well as the inhibition of the cellular respiration. In this way, the effect of the hydrogen sulfide is seen and the features are similar to the cardinal symptoms of the asphyxia. They will be seen. Additional to that, those many features will be seen in case of the hydrogen sulfide poisoning. Then to make the diagnosis of the hydrogen sulfide, we have to look for the certain features like the rotten egg smell is the important finding seen in case of hydrogen sulfide poisoning. If you notice a rotten egg odor nearby, it could indicate the hydrogen sulfide poisoning. Coin and jewelry changes its color. If you have coins and jewelry in your pocket that may darken due to the exposure of the hydrogen sulfide, then the blood sulfide level is important in making the diagnosis. By using the ion selective electrodes in combination with the Conway microdiffusion cells, levels above 0.05 mg per liter suggests the poisoning. Quick testing within 2 hours of the exposure is important. Then air test may be performed. In that, a simple paper with the lead acetate that turns to black on exposure to the air containing the hydrogen sulfide. Then the vital sign monitoring is important and that may suggest to the hydrogen sulfide poisoning. Patients with the breathing problems need the careful monitoring of the vital signs like the oxygen level in the blood. Blood and urine parameters shall be checked, although it is not for the immediate part of the treatment. Analyzing blood and urine can confirm the exposure of the hydrogen sulfide. Then in severe cases, doctors may check the blood for sulfide and thiosulfate levels to confirm the poisoning. In this way, the different features help in the making diagnosis of the hydrogen sulfide poisoning. Then for the treatment of the hydrogen sulfide poisoning, immediately remove from the exposure site and provide oxygen as quickly as possible. Get the patient away from the source of the hydrogen sulfide and provide oxygen as quickly as possible, preferably through the endotracheal tube. Then skin decontamination needs to be done if skin has been exposed. While hydrogen sulfide is a gas and usually doesn't require the skin decontamination, removing the patient's clothing and washing the skin with water and mild detergents can help reduce the odor-related issues of the healthcare workers. Oxygen therapy has a very important role in the management of the hydrogen sulfide poisoning. Administer high-flow oxygen. Hyperbaric oxygen therapy may be beneficial in the majority of the cases. Then treat the patient as per the different symptoms, like the treat bronchospasm with the nebulized bronchodilators and the steroids if necessary. Address pulmonary edema and the acute lung injuries with the continuous positive pressure airway ventilation, and in severe cases with the assisted ventilation. Control seizures with the muscle relaxant like diazepam, lorazepam and the midazolam. Then one of the important agent in case of the hydrogen sulfide poisoning is the nitrites. Nitrites are the antidotal in the hydrogen sulfide poisoning. They induce methemoglobinemia, which helps to counteract the effects of the hydrogen sulfide. Since hydrogen sulfide has the greater affinity for the methemoglobin than for the cytochrome oxidase, It dissociates from the latter and the binds preferentially to the former, resulting in the formation of the sulf-methemoglobin. We will be learning the details of the mechanism of this nitrite compound along with the cyanide poisoning, as this is used in case of the cyanide as well, and almost both have the same mechanism of action of the act of the nitrite. Then it is important to know the nitrite's dose given in the management of the hydrogen sulfide poisoning. Amyl nitrate pearl is broken and inhaled for 30 seconds every minute until the intravenous sodium nitrate can begin. So the starting measure is the inhalational route of the amyl nitrate, that is applied over the handkerchief, and that is asked to smell it for every minute and asked to inhale it for every minute until the intravenous sodium nitrite is given, and then the intravenous sodium nitrite is given in the dose of the 10 ml of the 3% solution amounting to 300 milligrams, that is given IV over the period of 4 minutes. Unlike in the case of cyanide poisoning, sodium thiosulfate is not necessary in the hydrogen sulfide poisoning because the body spontaneously detoxifies the sulf-methemoglobin. It is important to measure the methemoglobin levels when administering the nitrite therapy. It is important to measure methemoglobin level when administering the nitrite therapy. It must not exceed 30% level. Then for the monitoring of the hydrogen sulfide poisoning, monitor the patient closely for at least 48 hours for the complications such as acute lung injuries, dysrhythmias, peripheral neuritis and the neurological disturbances. Ensure the adequate oxygenation and the fluid valences. Watch for the development of aspiration pneumonia and the pulmonary edema. In many cases, supportive care and the oxygen therapy alone may be sufficient without the need of the nitrites. However, close monitoring and the appropriate management of the symptoms are essential for the best possible outcomes in case of the hydrogen sulfide poisoning. So, it shall be used very judiciously. So, the management in case of the hydrogen sulfide poisoning shall be done very carefully and the patient shall be kept under the observation. Then, in case of death due to the hydrogen sulfide poisoning, on the post-mortem examination, we may find the characteristic rotten egg odor, signs of asphyxia, though all the cardinal signs that we already discussed, we may see it on the post-mortem examination. The presence of sulf-methemoglobin in the blood can be quantified and the organ discoloration to the greenish is seen in the grey matter due to the formation of sulf-hemoglobin. The decomposition changes that we see first in the right iliac fossa that shows the greenish discoloration is because the production of the decomposition gases that mainly contains the hydrogen sulfide. That is why the decomposition color is greenish in color. So, it is very definite that at the time of the autopsy, it should be ruled out that it is not due to any decomposition changes and the color change of the greenish that is seen at the autopsy are because of the poisoning. So, we must rule it out properly. Then the pulmonary edema may be seen on the patients. Generalized visceral congestions with the scattered parenchymas may be seen. Then the certain other important facts related to the hydrogen sulfides are hydrogen sulfide exposure may occur accidentally or intentionally, posing risk to the sewar worker and warranting employer liability in the occupational disease cases. Accidental poisoning, often from the industrial incidents, are common. Hydrogen sulfide's rapid impact, termed as the slaughterhouse or the sledgehammer effect, incapacitates the workers, especially in the agriculture and the industry. Cleaning sewage with the hydrogen sulfide without much precaution poses a grave occupational risk. Schoolboys use the stink bombs containing the gas that may contain the hydrogen sulfide and may be dangerous in the crowded places. So, understanding the intricate properties, mechanisms, symptoms and the management of the hydrogen sulfide poisoning is very important medically as well as for the legal purposes. This is all related to the hydrogen sulfide. Then I would like to share an incidence with you. You're very well aware about the Bhopal gas tragedy. If I ask you what gas was used for that, you will immediately say it was the methyl isocyanide. So we will next study about the methyl isocyanide. To brief you with the facts, The Bhopal gas disaster occurred in 1984 in the city of the Bhopal, Madhya Pradesh, India, making one of the worst industrial accidents in the history. On December 3rd, 1984, approximately 45 tons of the methyl isocyanide gas leaked from an insecticide plant owned by the Indian subsidiary of the American firm, that is the Union Carbide Corporation. The toxic gas spread across the densely populated neighborhoods, resulting in the immediate deaths of the thousands and causing the panic as tens of the thousands attempted to flee the Bhopal. The final death toll was estimated between 15,000 to 20,000. Survivors, numbering around 500,000, suffered from the respiratory issues, eye irritation, blindness, and other health problems due to exposure to the toxic gases. Compensation of about few $100s was awarded to many survivors. Investigations revealed substandard operating and the safety procedures at the understaffed plant as primary cause of the disaster. In 1998, the former factory site of the Union Carbide was closed and transferred to the state of the Madhya Pradesh. In this way, the whole incidence of the methyl isocyanide poisoning occurred as a Bhopal gas tragedy. So, with this background, we will read the poisoning with respect to the methyl isocyanide in detail. Methyl isocyanide is a member of the isocyanide family, comprises toluene diisocyanate and the diphenyl methane diisocyanate (MDI), also known as isocyanate-methane and the isocyanic acid and the methyl ester. Methyl isocyanide present as a colorless liquid with pungent odor, transitioning to a gaseous state at 39 degrees Celsius. Methyl isocyanide is characterized by high reactivity, necessitating cautious storage. Interaction with the water induces an exothermic reaction, so it shall be used very carefully. Methyl isocyanide synthesis involves heating metal cyanates or the NL diphenyl N-methyl urea. Methyl isocyanide has the various industrial applications. Methyl isocyanide is pivotal in the manufacturing of the carbaryl, a carbamate pesticides. It serves as a crucial component in producing various polyurethane articles, including plastics, urethane foam, adhesives, or the polyurethane based products. Methyl isocyanide requires the meticulous handling and the storage due to its reactivity. It is always advised to address the potential hazards associated with the methyl isocyanide exposure and advocate for the stringent safety measures among the workers. Methyl isocyanide exerts its toxic effect on the body by mainly the two mechanisms. One is the causing irritation to the mucous membrane in the eyes and the respiratory tract, and another mechanism is inducing sensitization leading to an immunological response, particularly the bronchospasm. Isocyanates irritate the mucous membrane leading to the discomfort in the eyes and the respiratory tract. Isocyanates can induce an immunological response, potentially causing bronchospasm. The exact mechanism of the immunological response remains uncertain, but acute exposure is associated with type 1 hypersensitivity response, triggering an early asthmatic reaction. High concentration or the repeated exposure of the methyl isocyanide may result in the delayed IgG-mediated hypersensitivity reaction, leading to persistent airway inflammation after months or years of the initial exposure. Usual fatal dose in case of the methyl isocyanide poisoning is the more than 20 ppm. At 2 ppm, odor may not be discernible, but irritation and tearing may occur. Symptoms intensify at 4 ppm and becomes unbearable at 21 ppm. Breathing zone concentration of the 0.5 ppm are likely to evoke the respiratory responses.